Hello students, today I'm here to teach mathematics for grade 7 students. Before we begin our topic, let me revise few concepts done in the previous class. We have ray 1 and ray 2. When these two rays join together, they form an angle. And these angles have different forms or types. But when these angles come together or meet at one point, we get pairs of angles. So today we will continue our topic Angles and Pairs of Angles Part 2 and learn new concepts about pairs of angles. In the previous class, we saw what adjacent angles were. So let's recall adjacent angles once again. We have an angle COA which is divided into two angles. One is angle COB and the other one is angle BOA, which has a common arm OB and a common vertex O, with separate interiors for angle COB and angle BOA. Therefore, two angles which have a common vertex, that is O in this example, a common arm, that is OB, and separate interiors are said to be adjacent angles. Next is the complementary angle. We have angle AOB, which is also divided into two parts, or say two angles. One is angle AOD and angle DOB. So measure of angle AOD is given as 30 degree and the measure of angle DOB is given as 60 degree. When we add measure angle AOD and measure angle DOB, that is 30 degree plus 60 degree, we get as 90 degree, which is the complementary angle. So, if the sum of the measures of two angles is 90 degree, they are known as complementary angles. Now again, I have divided my topic into three parts. In my first part, there is a ceiling or the bridge that is shown, and this ceiling has two angles with a common arm and common vertex, which when added gives us 180 degree angle. This is a clear view of the ceiling or the bridge with two angles, and we can see that there are two angles and that angle is of measure 180 degree. So, if the sum of measures of two angles is 180 degree, they are known as supplementary angles. That is, when you add two angles and you get 180 degree, then those angles are called supplementary angles. Now in this example, there is an angle and we have been given the measure of one angle as 100 degree and the measure of other angle as 80 degree. So when we add these two angles, that is 100 plus 80, we get 180 degree. That is the supplementary angle. Now we will see one example based on supplementary angle. We have two angles. Measure of PQR is 110 degree and the measure of angle MNT is given as 70 degree. When we add measure angle PQR and measure angle MNT, that is 110 plus 70, we get 180 degree. That is, the sum of the measures of angle PQR and angle MNT is 180 degree. Therefore, angle PQR and angle MNT are supplementary angles. Now, we will see how to solve sums based on supplementary angle. So the first sum is, find the measure of the supplement of an angle of 135 degree. So an angle is given as 135 degree. We have to find the other angle. So let us consider the other angle as P degree, or say let the supplementary angle measure P degree. We know the sum of the measure of two supplementary angles is 180 degree. Therefore, 135 plus P is equal to 180 degree. Therefore, P is equal to 180 minus 135. We shift that 135 to the right hand side. So we get P is equal to 180 minus 135. 180 minus 135 is 45 degree. So we get P is equal to 45 degree. Therefore, the measure of the supplement of angle of 135 degree is 45 degree. We will see one more sum. They have given us the difference between the measures of the two angles of a complementary pair is 40 degree. We have to find the measure of two angles. So they have given us difference between two angles as 40 degree. So if we consider one angle as x and add the difference, that is 40 degree, in the other angle we will get the measure of the other angle as x plus 40. So let the measure of one angle of the complementary pair be x degree. Therefore, the measure of the other angle of complementary pair is equal to x plus 40, because they have given us the difference as 40 degree. So when we add x plus 40, we will get the other angle. Now we know the sum of the measure of complementary angle is 90 degree. So x plus 40 is equal to 90 degree. Now we'll open the brackets and we will get x plus 40 is equal to 90. We add x plus x, so we get 2x plus 40 is equal to 90. Then we shift that 40 to the right hand side, so we get 2x is equal to 90 minus 40. 90 minus 40 is 50, so we get 2x is equal to 50. Then we shift the 2 which is multiplied to x on the right hand side. So we get x is equal to 50 upon 2, because 2 is multiplied to x. So when you shift it to your right hand side, it gets divided. So 50 divided by 2, we get x is equal to 25. We have got the measure of one angle because we had considered the measure of one angle as x. So we got the measure of one angle, x is equal to 25. Now to find the measure of the other angle, we substitute the value of x is equal to 25 in x plus 40. So we get x plus 40 is equal to 25 plus 40, which is equal to 65. So the measure of the required angles are 25 degree and 65 degree respectively. In the second part, we can see an image of Brooklyn Bridge, where the pole holds the bridge, and from that pole the road goes in both directions in a straight line which leads to opposite direction. Let's say if we have ray BA and ray BC. The common point in these two rays is point B. So Can we join these two rays and make a straight line? Yes, because we have B as the common point. So, when we join two rays which have a common origin or a common point and which forms a straight line, then we call it as opposite rays. As opposite rays have a common origin, in a similar manner, we also have a common start. But we should understand in which direction one should choose to go to achieve his goals. Let's see one more example. Here in the first figure, we have two rays, AX and AY, with a common origin or the common point A, and which forms a straight line. So, we can term this line as opposite rays. But look at the other figure. Again we have ray AX and ray AY with a common origin or common point A. But it does not form a straight line. So, it is not called as the opposite rays. Now, we will see a sum based on opposite rays. Here, there is one figure given. We have to name the pairs of opposite rays in the figure alongside. So, we have ray PL, ray PT, ray PM and ray PN with a common point P, and these rays also have a straight line with the other rays respectively. See, this is ray PL. It has a common point P with ray PM. So this is ray PL and ray PM as two rays, and PN and PT are the other two rays with a common point P, and they form a straight line. Then in the next question, they have asked us whether ray PM and PT are opposite rays, and we have to give reasons for the answer. Now they have given us ray PM and PT, and they have asked us whether these two rays have opposite rays. So, ray PM and ray PT have a common point P, but these two rays do not form a straight line. So, ray PM and ray PT are not opposite rays.